Let's take a look at Newton's second law, right? For Newton's second law, this has got to be the net force. And when we say net force, it means the vector sum of all forces. Of all forces. Okay, and we're not going to get super heavy into the vectors here, even though we could, right? But just for an example, right, let's imagine that I've got, say, 10 newtons this way and 3 newtons this way. I would say, okay, that's positive 10, this is negative 3, so the net force is equal to positive 7 newtons, right? I just add those together, okay? And that's really all we have to ever do with this. The unit of force is newtons, and we'll look at that in a little bit here. Then Newton, after Sir Isaac, baby. Okay, and then mass, our mass is in kilograms, right? So 1,000 grams is a kilogram. So if they give you grams, divide grams by 1,000 to get kilograms, okay? If they give you pounds, laugh at them, because pounds is actually a unit of weight, not actually mass. But a pound on Earth weighs 2.2 pounds. Wait, a kilogram on Earth weighs 2.2 pounds. So pounds divided by 2.2 on Earth, right, is going to get you kilograms, okay? But really a pound and a kilogram are different things. One is weight, one is mass, and we'll talk about that a little bit later, okay? And then acceleration is, of course, suvat, right? Obviously, we can write problems where we have to solve for the acceleration. We can solve for it from this, right? We could solve for it from this. We could solve for it from this, right? Have I listed all the formulas, right? We could solve for it from this. Wait, that's the missing kinematic formula. Right? Any of these formulas that have an acceleration in it, you can solve for the acceleration. So let's look at a couple problems here, okay? Our first problem is what force causes a 4 kilogram object? What net force here? What net force causes a 4 kilogram object to accelerate at 6 meters per second? So I could just say, well, F equals ma, right? So it's, 4 kilograms times 6 meters per second squared, right? And I believe we are about to encounter our first, I think this is our first derived unit, right? Okay, and this ends up being 24. My units are kilogram meters over seconds squared, okay? But I could also write it 24 newtons. I could also write it 24 capital N for Sir Isaac Newton, right? So remember that 1 newton is a kilogram meter per second squared, right? And you can get it if you're like, where did that come from? It's just mass times acceleration. Mass is in kilograms, acceleration is in meters per second squared. There you go. All right, let's do something a little more challenging, because I can see you rolling your eyes like, Mr. Murray, this is not challenging enough for me. We'll try this one. All right, a 2.1 kilogram hammer accelerates from rest under the influence of a net force of 120 newtons. Right? We've added all the forces. They add up to 120 newtons. What is the final velocity if the force is exerted over a distance of 78 centimeters? That's worthy, right? This one, by the way, is going to be, let's solve, I think F equals ma first. And then we're going to solve a suvat, right? These problems are just like that. Sometimes you solve suvat first and then F equals ma. Sometimes you do F equals ma. And the reason I know is that I have F and M, so I can find A, right? So if you have 2 of these 3, you're going to do this first. So let's see. 120 is equal to, that's my force, right? Because it's in newtons, and it says it's a force. And that is 2.1 times A. So A is equal to, careful, dyslexics, be careful here. 120 divided by 2.1. Wow, that's cool. The acceleration is 57.14. I was expecting that to be like some weird thing, but it doesn't repeat at all. Let's see, 142857. Approximately meters per second squared, right? Is that right? Yeah, that's right. Okay, so now we can suvat, right? It's from rest, so this is 0. We want the final velocity, yeah. Displacement is 0.78 meters. Let's see, here's our acceleration. There it is, right? So 57.142857. And do we give a hoot about the t? We don't give a hoot about it. A hoot. All right, so v, I think I use no t here, right? V squared is u squared plus 2as, because that's what we're solving for. So v squared is 0 squared plus 2 times this acceleration, right? I'm just going to go dot, dot, dot. Only the dot, dot, dot probably takes as much time as, and then times 0.78. Okay, so I'm going to go square root of 2 times the answer I just got. I just burped it in there, times 0.78. I get 9.44. The absolute value of E is 9.44 meters per second. Is there any sense in which this could be negative? I don't think so. I mean, if this force is in the positive direction, this acceleration is in the positive direction, and so the velocity is that. Unless, of course, no, I guess if it started at rest. Yeah, so there it is, right? All right. We are good. Try some of the problems that are coming up next, and if you can't get them, look at the video. Figure them out.